This is a rerun of my presentation at my company, Abrigo. We are Windows shop and I wanted to see if we can develop in Linux so that we can start using Linux containers as our application deployment mechanism. To follow through this presentation, you will need to have these packages installed on your computer. I have links to those packages in the description. The basic idea of VSCode remote development is that you run VSCode locally and it connects to the remote server or container which contains source code or dev tools, and you run the debugging and compilation remotely while you get the benefit of rich local editing experience. I'm gonna launch Windows Terminal. This is one of the apps I mentioned. I have SSH server somewhere in my network. I'm gonna connect to it. The server name is Kenneth-Ubuntu. It's a Linux server. I don't have any files or folders, so I'm gonna create one. Maybe a file. I'm gonna launch Visual Studio Code. I already have remote extensions installed. Remote Development Extension Pack consists of 3 extensions: Remote WSL, Remote Containers, and Remote SSH. When you have any of them installed, you will see this green icon at the bottom left. I'm going to choose Remote SSH Connect to Host, add new SSH host, decide where to save the configuration, and connect. Now when you open folder, you see that it shows me the folders on the remote server, including the folder that I just created. I'm going to open it. And I can see that test file that I created. And when I make the change, it's visible on the SSH console. When I change the file, it's visible from Visual Studio Code. Now I'm going to create a Python file. And write a simple code. And I can run Python here, but I don't have Python installed on my local computer. So when I type Python, it's going to launch Microsoft Store. Now on the Visual Studio Code, I'm going to click this play icon and then run and debug and choose Python file. Now it opens this terminal and executes the file. Let's see what this terminal is connected to. It's the same server as the one that I connected from the Windows terminal. I'm going to put a breakpoint and run again. And you see that I see local variables. I can add watch. I can continue. The local variable and watch refreshes accordingly. I can also use debug console to evaluate values interactively. I can edit breakpoint. It'll skip 4 and then go to 5. I can also edit breakpoint to say stop when it hits 3 more times. So it provides pretty interactive debugging experience. I can create launch JSON file. Now what happened is it created this VSCode folder and created launch JSON file. Within this launch JSON file, I can save the profiles of how I want to launch the debug session. Now when I click the play button, I see Python current file on the drop down, which is matching with this one. And when I have Python file selected, I can click this play button and then it runs. Second extension that we will look at is remote WSL. WSL stands for Windows Subsystem for Linux. It allows us to use Linux natively on the Windows environment. It consists of the Linux kernel, which is open source managed by Microsoft, and you can install Ubuntu or other distros on top of the Linux kernel. With WSL2, we can use Linux file system on the Windows computer, which is much performant than Windows file system. When I have WSL installed, I can configure the Windows terminal to launch WSL by default. On my computer, I already installed WSL and Ubuntu distro, and it automatically adds Ubuntu entry on the Windows terminal. I can change the default profile. Now when I launch Windows terminal, it opens on the Ubuntu automatically. When I try uname A, you see that Ubuntu is installed on my local desktop computer. I can launch Visual Studio Code here. And it automatically triggers remote WSL. I can create a file here. And you see it's connected to the console, just like how we saw in the SSH demo. If you want to reach Windows file system from WSL2, you can do that. If you want to access WSL file system from Windows, you can do that by typing WSL$, then Ubuntu will show you the folders. On Windows terminal, you can also change where you want to start when you launch the console. On the settings, you can specify the starting directory, but note that you have to specify in the Windows path form. In this demo, we're going to use WSL only for a file system. So I'm not going to do any more demo, but you can see that it'll do the debugging just like how it worked in the SSH. Third extension that we are going to look is remote container. It allows us to use Docker container as a remote server. That means I can set up the dev environment as code in the Docker file, and once I have that, the same dev environment can be used by anybody in my dev team. Because it's Docker container, I can also keep the source code on my local computer and mount it to the container. I'm on my WSL console, and before you continue, you want to make sure you have one configuration of Docker. Even though I have Docker for Windows installed, Docker is not recognized by my WSL console. In the Docker settings, there is resources and WSL integration. You want to make sure this is checked, and also Ubuntu is turned on. Now you can use Docker command from your WSL console. I'm going to create a folder and launch Visual Studio Code inside the folder. It opened the folder under Remote WSL. I'm going to select Remote Containers Reopen in Container. It asks me which container do you want to use. I'm going to choose Node. I'll go with version 14. Let me try open a new terminal. You see it uses WSL2 kernel, just like how it was on my WSL console, but the computer name is different. My local computer's name is desktop something something, but within here the local computer name says 5B5D something something. That's the container's name. And you can also see the path is different. It says workspaces node test, whereas actual folder is tilde repos node test. When I create a file here, it's visible here. And when I change the content here, it's also visible here. So they are connected. The tilde repos node test is mapped to workspaces node test on this container. Now I have Node installed here. But I don't have Node installed here. Now I'm going to install Vue CLI. And I'm going to create a Vue app. Now you see that DevContainer created this my app folder. and it boilerplated the Vue app for me. Now all these files are also available on the WSL file system. Within my container, I can start and I can actually see the Vue app running. And I change the content. You see the hot reloading is also active. Let's see what just happened. On my laptop, I created a folder, and then I said reopen it in the container. Then Visual Studio Code created a DevContainer Docker file, which is immediately instantiated, then created a DevContainer. When I created the DevContainer, Visual Studio Code bound the WSL path to workspace's path. And it also binds Docker volume code VSCode to VSCode. We'll look into this a little bit later. It keeps all the Visual Studio Code extensions that I install on the DevContainer environment. Then I ran npm install vuecli. Keep in mind that I installed vuecli on the container itself. It's not available in the container image or WSL, only inside the container. Then I launched Vue create my app, which boilerplated files on my WSL file system. And then when I select to my app and npm run serve, it actually started the web application within the DevContainer, and then it mapped the local port to my desktop's port so that I can open it in my browser. Close the Visual Studio Code, and I'm going to reopen again. Visual Studio Code recognizes there is a DevContainer folder here, so it suggests, would you like to reopen it in container? I say yes. Then it revived the DevContainer that I've been using before. I still have vuecli. Now let me close this, and I'm going to delete the container that was created for me. Now when I launch Visual Studio Code again, it recognizes DevContainer file again and suggests, would you like to reopen in container? So yes. Then following the Docker file, it recreated the container. But note that I installed the vuecli on my container of the previous iteration, so I wouldn't have vuecli installed here. I don't think it's important to have vuecli installed on the DevContainer, but if you want to, you can modify the DevContainer JSON for the post create command. This command is executed after the initial creation of the container following the Docker file. So you could say Then when I recreate the dev container, it's going to execute this automatically. Let me try remote containers, rebuild container. When I open the terminal, I have VSCode installed. You can also install Visual Studio extensions automatically. For example, on this view file, I don't have the syntax highlighting enabled. For that, I want to install this Future extension. Visual Studio Code knows which extension to install on the remote side and which extension to install on the local side. In this case, Future needs to be installed on the remote side, and I can click install, or I can get this code and then specify in the dev container. Let me recreate the container now. And when I open the view file, you see the syntax highlighting is enabled because Future is installed. Let me open the terminal again. And if you look at the VSCode folder, you see that Future is installed. If you look at the dev containers show log, it shows details about how the dev container is created. And if you search for mount section, you will find that it mounted the source home cannot repose node test to workspaces node test, and also it mounted this volume called VSCode to VSCode path. This log file contains a lot of details, so I highly recommend you to look into this. I'm going to create another dev container using .NET Core this time. I'm going to create a new folder. And I'm going to launch Visual Studio Code. Again, it launched using remote WSL automatically. I'm going to reopen in container, and I'm going to select C#. Use .NET 3.1. I'm not going to install Node.js. The uname information on this .NET Dev container shows it still uses WSL2 kernel, but the computer name is EA90, whereas the computer name from the Node.js container was DE4E. And again, uname from my WSL console says desktop. I have .NET installed here, 3.1, but not here, nor here. Using .NET CLI, I'm gonna create a sample web API project. I can run it. And it created .VSCode on top of that .DevContainer. And in the .VSCode, it has this launch.json file, which says .NET Core Web, and it has pre-launch task named build, which is defined in the tasks.json file. Now, unlike the Python example, this launch profile is not current file dependent. So I can just press play button here, and then it's going to launch the project. The Web API project creates a simple Web API application with an endpoint saying weather forecast. When I compare the Docker file between the .NET Core version and Node.js version, you see that Node.js version says DevContainer's JavaScript node and $variant, where the variant is inputted from the DevContainer. Args variant is 14. In the .NET Core version, the Docker file says I want to use DevContainer's .NET Core, then variant. That variant is again coming from the DevContainer JSON file, where variant is 3.1. On this environment, I can debug just like how I debugged the Python file. In fact, it's running as debug mode right now, so if I put breakpoint here and refresh, it'll hit the breakpoint and I will see all the local variables, and I can add watch, or I can use debug console. Let me open another terminal, and when I do VSCode, you see that even though the containers are different between the Node.js container and .NET container, they share the VSCode, because you see this Vuter extension that I installed for Node.js container is visible from .NET container. That's because the same VSCode volume is mounted to the both containers. There are a couple of things that I learned from this experimentation. First, you want to use Git from the WSL2 console, not in DevContainer console. There are ways to manage Git credentials in the containers, and the documentation is available here. But I find it unnecessary hassle when you can just use WSL console. For Node.js app, you always want to use WSL2 file system only. It's faster than Windows file system, and Visual Studio Code allows us to clone the source code inside the container or clone as a separate Docker volume and attach it, just like how VSCode was attached. But I find it rather confusing. And if you ever edit the file using the Windows Explorer, you might face the line ending problem, because when you clone within Linux file system, it's going to use different line ending than when you do it in the Windows file system. But if you want to really use Visual Studio or Writer in Windows environment, for example for .NET application, you could git clone that in the Windows file system and then just open it in Windows file system. Just don't try to access Windows file system from the WSL side or vice versa. The remote containers show log gives you a lot of information that I didn't explain here. If you're curious about the source code of the DevContainer, it's available on this link. And I have a sample repository that demonstrates how to get the benefit of dev environment as code using Node.js and .NET Core on my GitHub repository called Vertical Slice. That's all I have today. Thank you for watching.